Yo, what's going on? It's your boy Jay Goo with another episode of MathLab. Today we're going to be doing your favorite, I know it is, factoring. It's not as hard as it may seem, so let's dive right into it. Okay, so the thing with factoring is you want to find the greatest common factor between all of your terms. That's our key goal, okay? And by terms, I mean these are your two terms. Numbers separated by logical operators, okay? So these two terms are separated by this subtraction sign here, okay? They're like terms because they both have x's and y's, okay? So first, we'll find out the greatest common factor of our coefficient, which is the number before our variables, okay? So looking at 18 and 21, I think that the greatest common factor between those two would be 3. Let's go through our numbers just to check. 1 works. 2, it won't work with 21 because 21 is an odd number. 3, it works. 4, neither one of these numbers are divisible by 4. 5, nope. 6, it works with 18 but not 21. 7, it works with 21 but not 18. 8, 9, 10, no. So it looks like 3 is going to be our greatest common factor. So we're going to pull that 3, we're going to put it out here. Okay? Next, we need to take the greatest common factor of x's. So that means we take all of these 8 x's from this term, then this one has at least 8. So the total amount of x's this term has is 11. The total amount this one has is 8. So the greatest common factor, or the greatest amount that they have in common, would be this 8. So we're going to take all 8 of those x's and we're going to write them out here by our 3. Okay, next we do the same thing with the y's. Our greatest common factor with the y's would be this 5, because this one has 7 but it has at least 5. This one has 5, so the greatest common factor would be 5 y's, right? So we're going to take all 5 of those y's, we're going to put them out here with our 3x to the 8th, y to the 5th. Okay, now this term, after you get this from both of these terms, that's 80% of the work. Okay, so this term here is just our greatest common factor between these two terms. Okay, now we can't just stop here. Now that we've taken what's in common between the two terms, right, we have to tell what's left over. Okay, with factoring, you should always be able to get back when you FOIL or you distribute this term amongst the other two terms it's being multiplied to. I'll show you here in a second. Hey, welcome back. I'm glad you got a chance to get a break and digest all this information. Now, let's go ahead and complete the rest of the problem. So, if we want to find what's left over from these two terms after we factored out the greatest common factor, it's easy. So, with the coefficients, we just divide our greatest common factor into the coefficient. So, we keep our sign, and 3 goes into 18 6 times. Not too hard. Next, we have 11 x's here on our first term, but we factored out 8. So how many more x's do we need to reach 11? Well, we need 3. So we're going to add x to the third. Because when you're dealing with variables and exponents, when we multiply these two terms out, if they have variables with exponents, you add the exponents. So the coefficients, or the numbers, you actually multiply, which will get us to 18. But for the variables, x to the 8th times x to the third is just x to the 11, because you add the exponents. Okay? Next, we're going to deal with our y's. In this term, we have all 5 y's, and we factored out all 5 y's. So when this gets multiplied towards this first term, you're going to have all 5 of your y's. So there's no need to add another y here. Okay? So we move on to our next term. And we do the same thing over for this 21x to the 8th, y to the 7th. So how many times does 3 go into 21? Well, it goes in 7 times. So we write our 7, right? We kept our sign. Okay? Next, we have 8 x's here. We factored out all 8 x's, so we have no need to add any more x's here. They are all accounted for. Okay? Next, we're going to go on to our y's. So we put our y here. We factored out 5 y's, and we want to get to 7. So how many more y's do we need? Well, we need 2 more y's. Because when we multiply this term times this one, you'll have 3x to the 8th, y to the 5th, times 7y to the 2nd, which will turn into 21 from our coefficients. Alright, x to the 8th, because there are no x's, right? Then y to the 5th times y to the 2nd is y to the 7th, because you add the exponents, which will give you the 7. So, boom, there's your solution. 3x to the 8th, y to the 5th, times negative 6x to the 3rd minus 7y to the 2nd, in parentheses. This, my friend, is factored. This is congruent to this. These are the same things, except this is a factor form. And if we want to check, we just FOIL and distribute this number here to both of these terms, and we should come up with this number. So let's go ahead and do that. So 3x to the 8th, y to the 5th, times negative 6x to the 3rd is negative 18, right? From our 3 and our negative 6. X to the 8th times x to the 3rd is x to the 11th because we add the exponents. Y to the 5th gets tagged along because there is no y's. Keep our sign. 7 times 3 is 21, right? X to the 8th, there are no x's, so we just tag it along. And then y to the 5th times y to the 2nd is y to the 7th because we add the exponents. This is exactly what we started with. You, my friend, have just factored.